Okay, so today we are going to be solving questions on rates, chemical reaction, chemical kinetics. Whenever you're solving a question that has an equation and they are giving you rates of consumption or production, we'll call this rates of reaction by stoichiometric coefficients. So I remember, no, this is what I wrote here. I said whenever you have to solve from an equation, you multiply given rates with the stoichiometric ratios of what you are asked to find over what you're comparing it to or getting it from. So let's take, for example, this question. We have nitrogen, hydrogen, and ammonia. So they now said, what is the rate of consumption of nitrogen and hydrogen that correspond to production of ammonia at 0.6 moles per minute. So they did not give us seconds but minutes. We can work with it. If we choose, we can still times it by 6. This is still the same, but we'll use this. So to get seconds, so I have N2 plus 3H2 then 2NH3. Then I'm giving production of ammonia at rate 0.6. So the rate at which this is being produced is 0.6 moles per minute. So for every minute, I don't think you understand what this per mean. For every minute you have 0.6. And we know that rate of reaction is simply given by, or you say rate of reaction is simply the amount of reactants by a given time, or the amount of reactants or products that is being used up or produced at a particular time, so per seconds. So if I know that, whenever I'm doing by stoichiometric coefficients, to find the rate of N2 here, I'll simply say what is the coefficient of N2 here is 1. Coefficient of hydrogen here is 2. Coefficient of ammonia here is 2. This one is 3, hydrogen is 3. So to get the rate of nitrogen, I'll simply say it is 1 mole for its coefficient against this one that is produced, which I'm giving the rate, all over 2. 1 over 2. So times 0.6. Whatever you get is the rate at which nitrogen is being produced. That is, nitrogen is being consumed at this mole, 1 mole of it, at when 2 moles, that is 1 over 2. As this is being consumed, you're producing 2 of this. So at a rate of this. So whatever you get from this is your answer. So let's try to punch it. So if I do 1 divided by 2 times 0.6, it gives me 0.3. So that is the rate, which is molarity per second. But this time around is in minutes. So I can say per minute. So that is for that one. Then to find the rate at which hydrogen is being consumed, that is A parts. So to find the rate at which hydrogen is being produced, I'll say when 3 moles of this is consumed, we have 2 moles of ammonia. So times the rates. So you get the point. So you see that this is going to be 3 divided by 2. 1.5 times 0.6, which is the same thing as 0.9. So mole per minute. This is my answer. So you need to understand that we can get rates by stoichiometric ratio. By stoichiometric ratio multiplied stoichiometric ratio multiplied by the rates, given rates. So it can be rate of production, it can be rate of consumption. We can also get rates by uh, differential method. In this differential method, for example, as I'm giving N2 plus 3H2 2NH3, is the same thing, is almost the same thing, but see what we are doing now. If I'm checking this, I will say this is the same thing as this is on the reactant part. I'll have minus 1 over 1. This is on the reactant part. I'll have minus 1 over 3. I'm looking at this one. Then this one now is on the product part. It will not have minus. I have, because why I'm putting minus is that it will be decreasing. This one will be plus because it will be gaining. Rate of reactant talks or reaction talks about reactant will be decreasing to form products. Reactant part will tend to be getting to a part where it's diminishing, while products, so that products can be formed. So this will be 1 over 2. Are you seeing it? So when I have this, I have this. By differential method, I will now come and say this is going to be change in N2 all over change in the time for it to happen. Change in H2 d of all over d of the t. So change in NH3 all over dt. But we don't always use this. So we can also get rates. The videos to this are on my channel. You can get videos on rates by differential method, by integrated method, by half-life method. What we are doing is by stoichiometric ratio. You can even get rates by initial concentration. We have video on that. You can also get rates by integrated rate law. You can also get rates by half-life method. So we can determine rates by any of these methods. So, but once you see an equation, if an equation is given and you want to determine rates, the first or the basic idea to use is this approach by stoichiometric ratio. All right, let's look at the second question. The second question here says, in the reaction magnesium, hydrogen chloride to produce magnesium chloride and hydrogen. This is a single displacement reaction. So suppose 24.3 gram of magnesium, but what we need is not gram, is mole. So they did not give us rates here. When rates, the rate of production, like in this case where they gave us to produce ammonia 0.6 moles per minute. So when it's not given, we can actually find it by doing ammonia, magnesium, is number 12 in the periodic table. So that means 12 times 2, the atomic mass will be 24. So 24.3 as well. So I have mole of magnesium will be equals to the mass over molar mass. So the mass given here is equals to 24.3 gram all over 24.3 gram per mole. So this is going to give me 1 mole. So the mole here, N, is 1 mole. Okay, now they said 1 mole. They said that this was consumed in 80 seconds. So I will simply do the rates of magnesium. The rate of consumption of magnesium will be equals to change in concentration of magnesium all over change in time. I'm not putting concentration. This is for concentration. Change in time. This is something I'm saying dmg all over dt. So this is something I'm saying 1 over 8. Let's check what it will give us. So 1 over 8 we get 0.0125. So mole per second. So mole per second. The minute we get this, we've gotten, notice that this is on the production part. Magnesium is on the production part. So the minute we get this 0.0125, we've gotten the rate of production. So to get what they said here, what is the rate of production of hydrogen in grams per second? So in grams per second, but what we have now, we've taken this to mole. So we'll go back to gram, but before that, let's go. We'll say rates here. Remember the formula. Stoichiometric ratio times rates. So the stoichiometric ratio of hydrogen, notice this is hydrogen. The stoichiometric ratio here is 1. Magnesium is 1. 1, 1, 1, 1. So it's simply 1 over 1 times 0.0125. 1 over 1 is 1, which gives me the rate of hydrogen. Rate of hydrogen gas to be equal to 0.0125 mole per second. But they're asking me to find it in grams. So let's take this. We know that mole is equals to mass over molar mass. And mass of hydrogen gas, atomic mass of hydrogen gas is 1 times 2. So it's going to be 2 mole mass over molar mass. Okay, 2 over molar mass, mass, yes, atomic mass of this is 1, sorry, 1. Then the molar mass is going to be 2. 1 times 2, 2. Then, watch, they say we should find it in grams, Shebi. Yes, we don't know this one, sorry, in gram. So, but we know this one. This one is 0.0125. So, by the time we cross multiply, and let's do it this way, 0.0125 equals to gram over 2. So if you cross multiply, by the time you cross multiply this, you get 2 into 0.125 gram, and this is going to be mass. So 2 times 0.0125 0.0125 is going to give me 0.025. So this is in gram, and you know that gram stands for atomic mass. So this is the atomic mass. So we can say that this is the gram of hydrogen that will be produced. So thank you. Remember to share, like, and subscribe.